Good afternoon, students. Just we are going to discuss today inverse trigonometrical function. Inverse trigonometrical function, basically this is chapter from the trigonometry, but it is more useful in the differential calculus or integral calculus. We are solving the problem in the differential calculus, finding the derivative of the inverse trigonometrical function, or doing the integration of the inverse functions, inverse trigonometrical functions. There, the inverse trigonometrical function concepts are much more useful we are using here. Before starting the inverse trigonometrical function, we will discuss what is the inverse function. Inverse function. First we discuss the inverse function. Suppose y equals to x plus 3 is a function. Y equals to x plus 3 is a function. To find the inverse of this function, what we will do? We will just replace y by x and x by y. So you can write that x equals to y plus 3. Now we can write y equals to x minus 3. So this is the f inverse x. So f inverse is x minus 3 now. So if the function fx is like this one, its inverse will be, f inverse will be x minus 3. Now, if you are drawing the graph of these two functions, that means the function fx, that is x plus 3, and its inverse x minus 3. While you are drawing the graph of these two functions, first function is fx equals to x plus 3. So when you are drawing x equals y equals to x plus 3, x equals to 0, y equals to 3, y equals to 0, x equals to minus 3. So the value we are getting in the x-axis, it curves at minus 3 comma 0, and in the y-axis it curves 0 comma 3. So if we join these 2 points, so this is the graph of y equals to, this is the graph of fx equals to x plus 3. Now, when you are drawing the graph of f inverse is x minus 3, here if x equals to 0, we are getting y equals to minus 3. And when y equals to 0, x equals to 3. So here it is x equals to 3 and 3 comma 0 we are getting, and y coordinate 0 comma minus 3. So if we join these 2 points, we will get the function, that is f inverse x equals to x minus 3. So yes, we have seen that the portion at which it curves the y-axis, at the same portion it inverse curves in the negative y-axis. Similarly, the portion at which the function curves in the negative x-axis, its inverse curves same amount of the segment in the x-axis. So as a whole, we have seen that function both f and fx are mirror image or image about the line y equals to x. So f inverse x are the image or symmetrical about the line y equals to x. Now, if I see that where these two functions will meet together, now we see that only if this is your fx, f inverse x will be like this. This is symmetrical about this line. But these two graphs meets only at y equals to x. That means we can say that the function fx and its inverse f inverse x touch each other or intersect at y equals to x. Both intersect at y equals to x. Both intersect at the line y equals to x. both can intersect together at only one line, that is y equals to x. So you can say that if you are drawing suppose we are drawing any function in the x-axis, the same graph portion will be plotted for the inverse function in the y-axis. Now we will discuss about the trigonometric function, that is inverse trigonometric function. But before that, we will discuss what is the minimum requirement for the function to be inverse. Suppose we have function f a to b. This is the function a, this is the function b. Function a has element x1, x2, x3, and it has element y1, y2, y3. Suppose we have function like that. Suppose like this is there. In the, so we can say the elements in the set A, that is called domain, that belongs to x1, x2, x3, and the element in the set B, that is called codomain, that is y1, y2, and range is f of x1, f of x2, and f of x3. Now range belongs to f of x1 means y1, f of x2 means still y1, f of x3 means y2. So this is your range. Now when you are mapping its inverse, that is from B to A, so here we are getting this is y1, y2, this is x1, x2, x3. So now y1 assigned x1, x2, and y2 assigned to x3. So this mapping shows that this is not a function, because one element is not possible in the function. A single pre-images will not have two images. So this is not function. So that means if you are doing this is the minimum function. But here if we are taking the inverse, the function is f inverse is for f inverse the function does not exist. That means you can say that function has to be 1, 1. Then only its inverse will exist. That means what I am saying, that if it is x1, x2, x3, and this is y1, y2, y3, all the elements will be assigned 1 by 1. Then now if it is f inverse B to A, so this will be y1, y2, y3, and this is x1, x2, x3. This is possible. This is one function. So here inverse, f inverse is possible. That means for a function to be inverse, it must be 1, 1. Okay, it must be 1, 1. So for inverse to be exist for any function, it must be 1, 1. Now the second condition I am going to discuss. Suppose we have a function a to b like this. Just wait. We have a function a to b. This is x1, x2, x3. This is y1, y2, y3. See here. Here for y3 there is no pre-images. So now when we are creating B to A, this is y1, y2, y3, and this is x1, x2, x3. So y1 is assigned with the x1, x2 is y2 and x2 also y3. So this is also not a function. So this is what, this is into function. But as far this is concerned, f a to be x1, x2, x3, y1, y2, y3. So if it is f inverse b to a, this is y1, y2, y3, x1, x2, x3. Here it is in onto function. So we are seeing that when you are keeping the function onto its inverse is possible. But when we are taking a function which is into function, its inverse is not defined as a function. So we can conclude that for a function, any function to have its inverse, it must be 1, 1 and onto. That is, it should be bisecting. So for every function, it is not possible to find its inverse. Only the function which is bisecting, for only those functions we can find its inverse. Okay. Now see here. Suppose we are taking just we have taken an example, fx equals to x plus 3. Okay. There also it is valid. X plus 3 is 1, 1 and onto function. So we can say that it is a bijective function, its inverse is possible, and we are drawing the inverse. Now, let us consider for the inverse trigonometrical function. For inverse trigonometrical function, let fx equals to sin inverse x. What I told just now, for a constant to have its inverse, it must be bisecting. Okay. Now, when you are plotting the fx equals to sin x, this is the fx equals to sin x. You know. F inverse and what is fx equals to sin inverse x? It's an inverse function. Same, what I told you, the function will be said only it will be plotted in the y-axis. It will be plotted in the y-axis. Like this. But this is for pi by 2, the value is 1. Okay. So if you are drawing this, it should draw like this. Like this. It should draw like this. And it should draw at like this one. Okay. Now see here, when pi by sin x, in sin x when x equals to pi by 2, we are getting the value 1. Okay. We are getting the value 1. And when it is minus pi by 2, we are getting the value, when x equals to sin x minus pi by 2, we are getting the value minus 1. Now when drawing the inverse function, here, it is like this one. Okay. Now see here, for finding the inverse, we cannot take entire function. This is the function. No doubt this is the function. But it is not a, if you are taking as a bijective function, okay, we have to take this segment only, this portion only. This portion. Why? Beyond this, the function will be many one function. Beyond this, the function will be many one function. That is the reason the value of the here x in sin inverse x, the value of x should be between minus 1 and 1. It should be between minus 1 and 1. That is the reason why you are taking. We will take this segment only, this portion, this inverse is not possible. That is the reason for y equals to sin inverse, the function exists. It's for the y equals to sin x, it inverse sin inverse x will be exist only the value of x is between -1 and 1. That is domain, you can say its domain is between -1 and 1, and its range will be -pi by 2 pi by 2. So that is the reason. Either it is cos inverse, tan inverse, whatever inverse trigonometric function, we have to take that only that portion which makes the function bisecting. That is the reason we are defining the domain -1 to 1. We cannot take the beyond 1 here, because we are taking more than that one. The value what? The function will be not bisecting. It will be many one function which is not defining its inverse. Okay, now we discuss some questions here. I think it's okay. Now for sin inverse x, what you see here, that means for sin inverse x to be defined, x should be -1 to 1. Okay. Now my question is, for what value of x sin inverse 4x squared minus 1 is defined? It's a very basic question. Now we know to define the sin inverse 4x squared minus 1, this 4x squared minus 1 should be between -1 and +1. So this is 0. 4x squared 2. So if you divide by 2, 4x squared 1 by 2. So x squared is less than equals to 1 by 2. Mod x less than equals to 1 by 2. So the value of x will be between -1 by 2 plus 1 by 2. This will be the domain for this function, or this is the value of x for which the function is defining. So this is the things we have discussed here regarding the sin inverse function. Now we discuss is more useful for finding some maximum minimum value or some ranges of the inverse trigonometric function. We discuss now. One question will based on this we discuss. One question I am writing. The question is the set of all values of x satisfying tan inverse x square plus cot inverse x square tan inverse x square plus cot inverse x square equals to, let's suppose this is x k pi q, then find the range of t. Okay. Otherwise we can ask find the maximum minimum value of this one. Other question we can ask find the maximum and minimum value of tan inverse square plus cot inverse square. Now see here, we have tan inverse x cube x square plus cot inverse square equals to, now this is a square plus b square. If you are using a square plus b square, we can get a plus b square minus 2ab. So now we can write as tan inverse x plus cot inverse square minus 2ab through tan inverse x into cot inverse x. This value we are knowing, this is equals to pi by 2. So pi by 2 square minus 2 tan inverse x. In place of cot inverse we can write pi by 2 minus tan inverse x. So this gives you pi square by 4 minus 2. So multiplying these two to cancel, minus pi tan inverse x minus plus 2 tan inverse x square. Suppose this is the value y. So we will find the maximum minimum value of y. All fine. Now see, let us consider tan inverse x equals to t. If you are considering tan inverse x equals to t, so we have y equals to pi square by 4 minus pi t plus 2t square. So for finding the maximum minimum value, what we have to do? We have to make a perfect square. So take 2 common, t square minus pi t by 2 plus pi square by 2. There is two methods to find the maximum minimum value here. Okay. First we discuss by making perfect square. Another one, you can use the quadratic concept and find the maximum minimum value. Now see here, this y equals to 2 t square minus 2 into 2 pi by 4. So it gives you pi by 2 plus pi by 4 square plus pi square by 2 minus pi by 4 square. So y equals to 2 t minus pi by 4 the square plus pi square by 2 minus pi square by 16. So y equals to 2 t minus pi by 4 the square. If you are taking LCM, 8 pi square minus 16 ना ठीक ओके ओके like this. So y equals to 2 into t minus pi by 4 square plus 14 pi square by 16 to multiply or 7 pi square by 8. To find the maximum maximum value, you can substitute here the value t is what tan inverse x. So you are substituting the maximum or minimum value of tan inverse x. We know the value of tan inverse x, the range of tan inverse x minus pi by 2 pi by 2. Between minus pi by 2 to pi by 2. So in between, if you are putting 0 here, what is the value then? If you are putting 0 here, 2 into 0 minus pi by 4 square plus 7 pi square by 8. So y equals to 2 into pi square by 16, 7 pi square by 8. So this is it. So y equals to 8 pi square by 8. That is pi square. Now when we are giving tan inverse x here pi by 2. So pi by 2 minus pi by 2 minus pi by 4. That is pi by 4. 2 into pi by 4 square plus 7 pi square by 8. So you are getting 2 pi square by 16. That is 8 pi square. 7 pi square by 8. So 8 pi square by 8. Still you are getting pi square. But when it being minus pi by 2, then in that case y equals to 2 minus pi by 2 minus pi by 4 square plus 7 by 8. So y equals to 2. This gives you minus 3 pi by 4, 9 pi square by 16 plus 7 pi square by 8. So y equals to 16 pi square by 8. So 2 pi square. So in this way you can find the maximum minimum value of that expression. So making a perfect square, we can find its maximum and minimum value. So we discussed these questions. And again we are going to discuss another question.
बंद कर देंगे ना चल रहा है